for Chris.
Now we're up and
yeah, I'm just waiting for Chris to switch host back to me because I don't know if there are people in the waiting room.
Okay, give them a minute then. Hi, Rosie. Good to see you.
Thanks for having me.
Well, we wouldn't think of doing it without you if we knew you were coming. Let's see. We are missing a lot of the regulars. Where's John?
Working, I think.
Oh dear. I know he was looking so forward to listening to you, Larry. Just can't get enough.
Well, he may come, but my guess is that he's working. So.
Okay. There's.
You got the host, Sue?
I do. We are good to go, I believe. You're good on your end?
So far, so good.
All righty.
Okay. All right. So you give your regular PA or public announcement there, Sue, about cameras and such.
Welcome to the April 8th HAA general meeting. As usual, we ask everyone to mute their microphones and turn off their video cameras so that streaming and screen sharing can happen seamlessly, and enjoy the meeting.
Okay. Hello, everybody. Welcome to spring, finally. I'm hoping anyway that it's going to stick around. It's not a false spring. We get a lot of false things happening around here. You know, false news and false skies and false clouds, and you know the problems. Anyway, my name is Bernie Vaness. I'm the chairman of the HAA. Glad to be doing it. Always a pleasure when you have a good group working around you to make things run sort of seamlessly. It's always fun. I'm not going to do an awful lot of preamble today because we do have quite a bit to get through. I know that we do not have with us the family Whitman, so I will be taking care of the draws myself later on. I'm advised to let you know that we have a couple of, we have two 8-inch Dobbs available for loan, and the 5-inch SCT is also available. Just contact Melissa at Lonerscopes at amateurastronomy.org, and she'll take care of you. Okay. So usually we start off by introducing and having our speaker come on, but I'm going to do it a little different today because his information is complementary to what I have to present to you today. And I'm flickering all over the place. Let me turn off my camera and then I'll come right back on and hope that that resets that. Where is my camera? There it is. Okay, come on back on. Come on. Oh, sure. We are going to have some difficulties tonight. Yep. Okay, I'm getting a cannot start video for some reason. Well, let's hope that my screen sharing will work, because if it doesn't, then we have a real problem. So I'm gonna go straight to screen share, and I'm going to run a presentation here talking about the moon and what we can do about it being in our way. Oops, let's try screen share first. Come on, where are you? Screen share. That one, I think. There we go.
We can see your screen, Bernie.
Okay, good. Get out of there. There we go. Okay, so I'd always like to start with some pretty pictures. There we go. This is an eclipse from 2007, if I remember right. Yes, August 28th, 2007. Gorgeous picture. Love the colors in this. So the moon, there we go. A few facts about the moon. We're gonna be talking about it. The moon, a bit about the history of the moon, how it came to be. It's believed to have come to be from coalescing of material floating around the Earth's orbit and possible collision with something else. Of course, we can't go back and know for exact sure, but that's the theory. A few facts about the moon. You know, the moon's we jumped a page, I think. Where are we? That's slide 3. We jumped one, go back one. That's 2, okay, 3, okay. The moon was formed in various stages. After it coalesced somewhat, there were impacts and it continued to grow and it went through different eras. And we're touching on this because you may want to know this later on. Each of these eras is unique in its own way and it's definable through observation. As you can see, there are certain areas that are predominantly one era or another. I'm going to jump here. There's 6 of them to worry about or to be concerned with. A lot of astronomers, a lot of astronomers, the moon is just a pain in the eyepiece. It's bright, it's in the way all the time, it's big, it's a big ball of rock. It's roughly the quarter of the diameter of the Earth. And as you can see on the overlay, the size of the continental United States overlaid on the moon, to give you an idea of the size of it. It's big, but it's not as big as you might think. It runs through phases. So it never stays in one view. And as you can see, it runs through very definable phases. It's always on the move. It has an orbital speed of about 2,200 miles an hour. And that's almost the diameter of the moon. So it makes it the only celestial body that moves through space at its own width per hour. So if you ever want to keep track of the time when you're out there and you see the moon, well, you know, the moon's going to move 1 moon width per hour, give or take a bit. The shadow is always moving. The Terminator, it moves at 16 kilometers an hour. Compare that, the Earth's Terminator moves about 100 times that speed at about 1,650 kilometers an hour. That's at the equator. The orbit varies. You have a perigee of about 362,000 kilometers and an apogee of 405,000 kilometers. That's why we get our supermoon and our mini moon and such. But it always takes the same amount of time to travel around the orbit or around the Earth. To complicate things, the moon's orbit is tilted. And that helps lead us to libration. And we get an effect of the moon doing or appearing to do what the illustration here is, the animation is showing here. Although it's got one little extra move in there, I just noticed. It's a photo hog, the moon. It just takes your attention away when it's up there and you just have to take pictures of it all the time. It's not content just to be bothering us at night. It sticks its nose out in the daytime as well, which is good. Actually, it gives you something to do in the daytime. It also helps you find things in the daytime. Without the moon as a guidepost, a big guidepost in the sky, it would have been very hard for this observer to have found Jupiter They may have found Venus. That'd be pretty simple, but to find Jupiter by itself, it would have been a bit of a difficult task. It has things that are there that aren't there. Clair obscure effects. Those are things that you think you see, but they're not really there. Things like Lunar X and the Lunar V. And this photograph is from Paula, one of our members. And I've marked the positions of those pieces. And incidentally, the X and V is visible tonight, but right now, but it's only over in Europe that can see it. We won't see it here. So that moon is just a pain in the butt. You go out, you look up, it's there, you shake your fist at it, but then you pause and you go, well, it's in such and such a phase, and how long until we get rid of it? But next thing you know, you're actually observing the moon. And that brings us to the Hamilton Amateur Astronomers Lunar Observing Program. Ta-da! The observing program will consist of 100 targets, consisting of 68 craters, 6 maria, 10 mountains, and 16 other formations, the smallest of which is a little crater in here called Linney. It's very small. It's 12 kilometers across, but where it sits is very visible. So it should not be too much of a difficult task to see that. Oh, we talked about the events on the moon, or the epochs. The moon is still growing. The moon is still changing. And every once in a while, someone will catch an impact on the moon. One happens to be on the left here. This was taken in 2019 during the eclipse. Somebody caught an impact. Another one, the other one on the right was in 2013, a very nice impact, which left a crater that unfortunately is too small for most of us to see. Speaking of small, you will, if you're out looking at the moon, you'll always have somebody, almost any night, have somebody come up to you, walk up to you and say, well, can you show me the flag on the moon? Or can you show me the lunar lander or something? Well, you can't. And I'll tell you why we can't. The lunar lander module is about 4 meters across in size. So to see that, you would need a telescope that's 56 meters diameter. And that's only to see it as a very tiny, tiny dot. The Hubble is 2.4 meters across. It can't even see it. The world's largest terrestrial telescope is 10.4 meters, and it can't see it. Here, a little bit of education about what it would take to be able to see it. There's a formulation, 116, which is Dawes number, over the aperture of your telescope. So an 8-inch telescope is 203 millimeters in aperture. 116 divided over 203 equals 0.571 arc seconds. That would be your resolution on that telescope. You take that resolution and you work the apparent size of the moon. Remember, the moon does move back and forth against us, so that 1800 will change as time moves. And then you also have the diameter of the moon, which is stable at 3,474 kilometers, or I've also read 3,472 kilometers. I don't know where the 2 kilometers disappears to, but I don't know. But you take the diameter of the object, divide that by the size of the apparent size of the object, and you come to a measurement of 1.93 kilometers of surface area per arc second. And you take that 1.93, multiply it by the resolution of your telescope, and your resolution will come down to 1.1 kilometers. So your 8-inch telescope, you will resolve down to about 1 kilometer. Now, that doesn't mean you'll see any definition. That's the minimum appearance of an object. So it would be just basically a dot, if that. This is subject to a whole lot of other things like the frequency of light and the time of day and the atmospherics and so on and so forth. But this is the mathematical side of it. So now with your telescope, what's the smallest object you can see? I'm not going to make you work it all out. Here's a table for you. So just look on this table, find the size of your telescope. Okay. So I've got them going from, what's that, about 4 inches up to 14 inch. And there's the sizes of your object that you'll be able to see, the smallest object. Again, that's the minimum visibility of the, or minimally, it's the littlest you can see. How's that? There we go. I've done the same with binoculars, but I forgot to change from the 1/16. It's a different number, but it's approximately the same amount of resolution. So anyway, the references that I've used in putting this program together are quite a few, actually. I've used, and I suggest you use these, the field map of the moon, which is available from Sky and Telescope. It comes in 2 versions. There's the regular version, which is upright, right is right, to the mirror image map as well. So depending on what type of telescope you have, you can use that. The Sky and Telescope also puts out a card map with 100 lunar objects on it. The objects in this program are not all marked on this map, but it's a good little map to have with you that you can mark stuff on. Being cardboard, you can mark on the location of some of our objects. Got a couple up in here, and take that out with you. The atlases, the 21st Century Atlas of the Moon, my favorite. I love this book. It's a great book. It provides images up and right, so correct image. The Hatfield, the Hatfield comes, I found out, comes in a couple of different varieties. So it'll show it in correct image, it'll show it in reverse image, it'll show it in reverse crossed over image as well, in each separate volume. So that's available to you as well. This is the 6-inch Lunar Atlas. It's designed specifically for 6-inch telescopes. The photographs in it, it gives one of each view. So you've got your upright, your reverse, and your reverse doubled. Oh, I'm sorry, jumped. If you want to find stuff on the interweb, as it's colloquially called, there are a couple of places you can go. All of this information is available with the printouts and the download for the program, so you don't have to be scribbling all this stuff down. Of these two, the one from the Inconstant Moon, Senelographia, provides the Ruckel maps, but it unfortunately makes a very small image. If that image were the size of the page, that would be absolutely perfect. So instead of that, you can go to Virtual Moon Atlas. It's a great, great program. Just download it. I don't know if there's a downloadable version for your phone. I'm not sure. I include the Moon Tool. Moon Tool is, it's just a little thing that sits up in your corner of your computer. When you click on it, it opens up like this, not quite as large as you're probably seeing it. You have a couple of options. You can enter in a Julian date or a standard date. Most of us will go with the standard date. If you're using the standard date, it's universal time. So remember to adjust our time to universal time. Enter the date and such, and you click on, and it will give you an image of what the moon looks like. Not enough for finding stuff, but it'll also tell you the exact age of the moon to the minute, the phase. It'll give you the distance away. Like right now, as of, well, about a half hour from now, the moon will be at 404,000 kilometers away. And its size, remember I said the size changes? There's your actual current size and the distance and so on and so forth. And if you're curious, it'll also show you what lunation you're in and when the next phases are. It's a very handy little thing to have. Textbooks, there's always, and you know me, I love my books. I've got books galore. Firefly Moon Book, which is one of the books that's being given away today. It's a great book to have. Exploring the Moon through binoculars and small telescopes, another very good book. 50 Things to See on the Moon by Reid is the second of 3 giveaways today. What's Hot on the Moon Tonight is a very, very good book. Andrew Plank put it together. It's a couple hundred pages, large print, well diagrammed, goes through on a day-by-day aging of the moon and talks about the different objects that are available on the moon or that are on the moon to be seen, and some challenging stuff in there too. Lunar Cognitum is a 3-volume set. If you want to get serious about observing the moon, this is the set that you might want to get. That set will run you currently about $100 for that set, which is not bad for a 3-volume set. Let's see, going down. Okay, so the list of stuff. The list starts off with the first page. And on the first page, you will enter your equipment that you're going to use. In this case, this is a Vixen R130 SF. It has a 130 millimeter aperture with a focal length of 650 millimeters. Just a nice little 5-inch reflector. It starts with the lunar days. So between days 2 and 4, you're suggested to observe Fernarius, which is a pre-Nectarian epoch object, target. And then I've given you a little bit of notes about it. It's an old eroded crater with ejecta on the floor. And it's part of the Gang of 4, and you'll learn what that is. It's 135 kilometers in diameter, and from peak to floor is 3,920 meters. It's on the Sky and Telescope map. That was the fold-out one from Sky and Telescope. It's in section SE N16. On Ruckel, its map is G6. So now that's the information you need to find it. Now you do the work from here. Write down the size of the eyepiece that you're using. Then you're going to calculate for me the power of the magnification, the amount of magnification, which is simply the telescope focal length, which is 650, over the eyepiece length. In this case, it's 12. I don't know why I've got 18 written down here, but it works out to 92 magnification. If you were using an 18 millimeter, it would come to 36. I'm not worried about the decimals on this. And you run your date and your time, April the 8th, today's date, 2022 at 2100 hours. So that's an hour and 10 minutes from now. And then your comments about what you observed. And in this case, it's can be as simple as it's one large and several smaller craters on the crater floor are involved in there. Doesn't have to be a lot of information, just enough so that I know that you found it. If you want to put more information, write it on the back of the paper. Just write the name of the crater, and we'll figure it out from there. So we go from there. And of course, I just told you all this stuff, the lunar date and the formal name, Fernarius. I'll also give you the common name. When you get to the date and time, very important, and this is in all of your observations, I suggest you do this, write out the name of the month, okay? Because 5/12/2022 is either May the 12th or December the 5th. And 15 years from now, you may not remember. So write it out. AM or PM also helps, although if you're viewing the moon, well, as I pointed out, you can view the moon in the daytime too. So AM and PM would help, or use the 24-hour clock. Doesn't matter which one you use. Try to be consistent in what you use. And you get the list, and this is what the list looks like. There's about 12 pages, give or take a bit. Pretty simple. Anyway, you get all this done, or as you notice here, there's Mercurium, where I give you the common name, some more information about it. I tried to give you a little bit of information about them, but not enough to confuse you or take away from your viewing experience. When you get it all done, there's another page. It's not in yellow. It just happened that this turned out yellow, where you put your name and your contact information and stuff. And what we can do is send it to you, or hopefully we'll be in person where we can present certificates to you. I haven't found a chocolate bar yet that I can coordinate with the lunar program, but I'll work on that. Anyway, that's the program in a nutshell. Any questions on this? Please, thank you. Where is everybody? That's it? Or?
Ernie, I don't see anything in the chat. Joanne said, awesome and thank you.
Oh, thank you. Thank you. That was easy. Okay, stop share. There we go. Yeah, I don't know that I can, I'm still not getting my video back for some reason. Start video. Oh, there I am. I'm back again. Good. Okay, well, that was easy enough. It didn't take as much time as I thought it might. So now I would like to introduce Larry McHenry. Larry, you can turn on. Oh, there you are. Good. Larry's here to talk to us about the second part of this or first presentation, how to observe the moon for beginners. What do you think of my little program there, Larry?
Oh, it was excellent. It was great. Very, very well done. Thank you.
Well, thank you. I hope I can get some people out there taking a look at the moon. That'd be great. Anyway,
hopefully between the two of us, we can inspire them to get out tonight. So
I certainly hope so. So the floor is yours too. Now we usually take a break at about 25 or 22. So you have a clock in front of you, I presume.
all right. So okay, so I should only take up about 25 minutes or so of your time.
Perfect. That'll leave for conversation and questions.
Hopefully, maybe a little bit of both. We'll see how many we get. So let me share my presentation.
Okay.
Find it.
Floor's all yours.
All right.
I'm going to try to duck out of here without destroying my video again.
All right. I'm going to stop. Let's see here. Sharing my, whoop. So let's see here. So let me know, let me start this up. You see my banner page, Observing the Moon for Beginners?
Yep, you're there.
Awesome, great. So good evening, everyone. My name is Larry McHenry. I'm an amateur astronomer from the Pittsburgh area. I'm a member of the Kiski Astronomers and the Oil Region Astronomical Society from Western Pennsylvania. And I'm also a regular at Cherry Springs, where I met Bernie and a number of other folks there. And hopefully I'll get to see you there this summer. Again, welcome everybody to tonight's presentation. Tonight, I'm going to spend a few minutes introducing you to our nearest neighbor in the solar system, the moon. So the moon is one of the favorite objects of non-deep sky stargazers. It's the brightest and easiest nighttime object to find. It's also closest at about 240,000 miles. Now, viewed with the unaided eye, the moon appears to be a bright sunlit world made up of light and dark patches. In reality, the moon is actually very dark gray in color. It appears white to the eye because of the great difference in seeing a sunlit object against the dark night sky. Now, ancient people saw various shapes in these light and dark patches, from oceans to resemblances of animals or human faces. Many cultures associated a goddess with the moon. In China, there was the rabbit in the moon, said to be the companion of the moon goddess Chang'e. The Incas called their moon goddess Kilia, who would cry tears of silver. They believed that lunar eclipses were caused by a serpent attacking the moon goddess, and so the Incas would try to scare away the serpent by making loud noises. And of course, the ancient Greeks and their moon, their goddess Selene, who would drive a silver chariot pulled by a couple of horses. But after Galileo turned his telescope on the moon in 1609 and into 1610, astronomers began to realize the true nature of the moon, that the moon is an airless, barren, geologically dead, rocky world. Well, the first thing that Galileo noticed about the moon is that it did not have a smooth, celestially perfect disk as he had been taught in school. Using his new telescope, Galileo instead observed that there were mountains, valleys, and large flat plains pockmarked with depressions that we know of today are craters. Well, at first, Galileo wasn't sure what these depressions were, if they were true depressions or if they were just small hills. But by noting along the moon's jagged, uneven terminator, how the shadows and the illumination of the crater walls and their interiors would change from where the sun was positioned, just like watching shadows in an earthly landscape, he was able to determine that these objects were actually holes and pits in the lunar surface. He was also able to use the same play of shadow and light to measure the angle of the mountains using simple geometry and calculate their height, finding that peaks taller than any known on the Earth at that time. So, where did the moon come from? Well, there have been a number of theories advanced and discarded over the years. For example, astronomers used to think that the moon and the Earth were double planets, so they formed together at the same time in the early days of the solar system. Then they thought that perhaps the moon was captured. It was, all these different objects formed out in space, and the moon just sort of wandered by the Earth, and the Earth being larger, its gravity captured the moon. And then there was a thought for a while of fission, that the young Earth was much larger than its current size and spun much more rapidly on its axis. So a big blob of it kind of flew off and formed the moon. I think it was a bad 1950s sci-fi kind of loosely based on that. But the current theory, is impact. And it's believed that about 4.45 billion years ago, in the very early days of the solar system, while the Earth was still forming, that a large object that they believe to be about the size of Mars hit the Earth at an angle. Now, it wasn't a direct head-on collision, otherwise we wouldn't be here having this presentation tonight. It was, again, kind of a glancing blow. But the impact threw debris into space from the Earth and the other object, and they condensed around and to form a moon. And interestingly, for a while, the planet Earth actually had a ring around it, just like the planet Saturn does. So here's a slide on some basic moon facts. I'm not going to read through all these, but you can find this type of information in any good astronomy book on the solar system that has a chapter on the moon. Again, distance from Earth about 240,000 miles, diameter about 2,100 miles, or again, 27% of the Earth's diameter. And an interesting little factoid that I learned is if you could take the moon and flatten it down like a pancake, then take the Earth and flatten it down, put the moon on top of the Earth, stack them like pancakes, that the moon would almost stretch from the East Coast to the West Coast. Again, moon's gravity, 16% that of the Earth's. And another feature I find interesting is that the moon's surface temperature If you're standing in sunlight on the moon, the temperature is 130 degrees Celsius. If you take a couple steps over to a shadow of the mountain, it plummets to a minus 180 degrees Celsius, a huge range in temperature differences. This is why the astronauts had those big bulky spacesuits to protect them from that big swing in temperature. Now, the first thing you notice when looking at the moon is its phases from, waxing crescent, first quarter, full, waning crescent, and so on. The phases are caused by the way the Earth, the moon, and the sun line up in their orbits. Here's a good slide showing the different phases. You've got the sun over here, sunlight. Here's the Earth with the moon going around it. When the moon is between the sun and the Earth, we can't see it. That's what we call a new moon. Then as the moon gradually moves through its orbit, first you see a waxing crescent. When it gets to a 90-degree position from the Earth, that's first quarter. Waxing gibbous, when it's a full 180, you see the full moon, and then it starts going back, waning gibbous, third quarter, waning crescent, back to new moon. Now, it takes the moon about 27 days to complete one orbit of the Earth. But because the Earth is also moving, it really takes 29.5 days for the moon to catch up to the same point that it started from in its orbit around the Earth. This is where our calendar comes from. It's based on the lunar month. You may also notice that we always see the same side of the moon. This is because it takes the moon the same amount of time to make one rotation on its axis or spin around as the same amount of time that it takes the moon to revolve around the Earth. This is due to the Earth's gravity having slowed down the moon and locked the moon's rotation to its orbital period. Thus, we always nearly see the same side of the moon. Now, occasionally, when the geometry is just right, the sun, Earth, and moon align such as the Earth's shadow falls on the moon. This is what causes lunar eclipses. So the Earth, like every other object out in space, casts a shadow from sunlight. So the moon's orbit occasionally takes it into the Earth's shadow, and depending on how deeply it goes into the shadow will determine whether you get just a partial eclipse or a total lunar eclipse and how dark that eclipse will be. Here's an example of a lunar eclipse from a few years ago. One of the interesting things you may notice, as opposed to a solar eclipse, which is over in just a matter of minutes, a lunar eclipse lasts anywhere from an hour and a half or longer. Here's another example from October 2014 of a lunar eclipse. This time the moon was closer to the horizon, which looking through all our atmosphere gave it more of a reddish tinge, what they call a blood moon. And of course, if you're really lucky, maybe while you're observing a total eclipse, you might get an airplane fly over it. Kind of fun. So an even more rare event is when the moon passes in front of another object, usually a star. This is called an occultation. And occasionally the moon will pass, and there's a couple of bright star clusters that we are all familiar with, M45, the Pleiades, and M44, the Praesepe cluster. The moon will occasionally pass through those two star clusters, and it can be quite fun watching the moon slowly move through the cluster, eclipsing individual cluster stars. The moon also occasionally will cross the path of one of the planets, for usually, well, the outer planets, such as Mars, Saturn, pictured here, Jupiter. And it can be, quite interesting watching it cover a planet, because it's not instantaneous like a star where just, it star's there and then the star's gone. The planet takes a few minutes for it to disappear. Now, as you observe the moon going through its phases, you may notice what looks like a line that divides the moon and separates the light portion of the moon from the dark portion. This line is called the Terminator, and it marks where sunrise or sunset is occurring on the moon, depending again on what phase that you're observing. The Terminator slowly advances, keeping with the moon's orbital motion. It can be very interesting watching the tops of mountains appear or the walls of a crater slowly covered over by darkness. Here's some examples of one. This is the crater Magennis. Has a little cleft in the crater wall, and at sunrise, it lets a ray of sunlight across the crater floor, illuminating the mountain peaks on the crater. Kind of a fun thing to look for. Here's an example of Copernicus. Here it is just on the left-hand side, just at sunrise over Copernicus. The sunlight's just starting to illuminate the edge of the crater walls. And then here we are nearly 24 hours later, almost the entire interior of the crater is now illuminated, just a little bit of shadow remaining along one of the crater rims. Also, something interesting to look for around the Terminator is what we call I guess you would call it transient lunar phenomena. An example of that is the Lunar X. This is sunrise on the rims of craters Lacaille, Blanchis, and Purbach, and it always occurs around first quarter moon. But again, if you can catch it, it does look like a little X marking the spot there on the lunar surface. Another interesting transient phenomena is sunrise on the Jura Mountains, which occurs a few days before full moon. This event is called the Golden Handle. And what happens is the peaks of the Jura Mountains catches the morning sun rays, and it illuminates them. It kind of looks like a little handle of golden light up there that you wish you could reach up and grab. Now, also a few days after new moon, when it's a thin crescent, you might notice that the dark portion of the moon is really not very dark. You can faintly see details on that dark area of the moon. This is called earth shine, and it's caused by sunlight reflecting off the Earth's oceans, clouds, and atmosphere, faintly illuminating the entire moon, including the portion not directly lit by sunlight. Now, as the closest object to us, the moon shows much more detail than anything else up in the night sky. Being so close, the lunar surface shows a feature-filled landscape visible through any telescope. When you observe the moon using binoculars or a telescope, you'll notice that there's three basic types of lunar terrain or surface features that you can see: lowlands, highlands, and craters. And this particular image here has all three of those types on it. Let's talk a little bit about each one. So lowlands are made up of the Mara. The Maria or seas are large, flat, dark gray plains. Well, soon after the invention of the telescope, people actually thought that the moon had water, plants, and animals just like the Earth. And they thought that the Mara were oceans, and perhaps there were other people up there sailing on those oceans. But the Mara are actually huge impact basins that were filled in after the initial asteroid strike by molten lava erupting from the lunar interior through fissures in the crust created by the stress of the impact. This slide here shows all the major near side Mara. Of course, one of my favorite Marae is Mare Crisium. Mare Crisium, or the Sea of Crisis, as it's called, is about 345 miles in diameter. It's estimated to be about 3.85 billion years old. It has a very flat floor with a ring of wrinkle ridges toward its outer boundaries. Has a number of ghost craters that have been largely buried by lava upwelling and covering them. And also the crater Picard can be seen just to the west of the Mare with its bright rays visible. Another favorite one of mine is Mare Humorum, the Sea of Mist. It's, again, another large lava plain, about 265 miles across, aged about 3.9 billion years old. Its basin is filled with a thick layer of basalt lava, believed to exceed 1 mile in thickness at its center. You can also observe low curved wrinkle ridges formed by the cooling lava. I guess you could think of the lava like when you bake a pie, how the crust shrinks down after it starts to cool. Same thing here. It has many small craters formed by younger impacts that hit the Mare after it formed. And also on the northern edge is the large crater called Gassendi. And you can have a little bit of fun with the Mare. Just using your eyes and a little bit of imagination, you can come up with various shapes made by the dark patches, such as the man in the moon, the woman in the moon, the rabbit in the moon, and everybody's favorite, the cow jumping over the moon right before new moon in the morning. Now, the second type of lunar terrain are bright areas made up of mountains and ridges, and along with craters, highlands cover about 2/3 of the surface of the moon. Some examples, of course, ridges. You can see various ridges on the moon. Mountains, again, here's the Jura Mountains, Cape Hercules. There's the Apennine Mountains, Mount Hadley. You see it casting a shadow there. And also here's other mountains, Mount Piton, catching the first morning rays of sunrise. A lot of interesting mountain features on the moon that you can look for with your telescope. Now, when you look at the moon, you see written on its surface the history of our corner of the solar system. That history is full of violent collisions and impacts. The moon has been an ancient target for wandering space debris, and its surface is pockmarked with the most common landform of the solar system, impact craters. Now, craters are the third type of lunar terrain, and a very few number of craters might be old volcanoes that you can see, but the vast, overwhelming majority of craters were made by asteroids or comets that crashed into the moon millions and billions of years ago. So how do craters form? Here's a good slide with that information. Basically, you have the impacting object, whatever it is, comet, asteroid, coming in, hits the surface, vaporizes, creates a shock wave. It creates a compression wave under it that compresses the surface. And then that compression wave eventually refracts backwards up, and it ejects material. It creates a fracture system under the impact area. The ejected material falls back over, creating an ejecta blanket. Again, as part of the refraction, the surface bounces back. It forms crater walls. It can form a central mountain peak in a crater. And again, depending on the fracture system, how deep it goes, it could allow molten magma from the interior to rise up and fill the inside of that crater up with lava. Now, because the moon has no atmosphere or weather, there's no wind or rain, most craters have changed very little from the day they formed, unless perhaps another impacting object comes down and lands nearby and disturbs it. Craters come in all sizes. They can be as small as a dinner plate, others as big as a large city or a small state. They can be anywhere from just a few inches deep to thousands of feet deep. They can have tall central peaks or walls formed by the impact and extensive bright ray systems formed by ejected material. Even a small telescope will allow an observer to see dozens and dozens of craters. Well, one of my favorite craters is that called Plato. Plato is about 61 miles in diameter, has walls rising to about 6,000 feet. The age of Plato is estimated to be about 3.84 billion years. Sections of the inner walls of Plato display signs of past landslides where the steep crater walls eventually slumped down. The floor is free of significant impact craters, post-impact craters, and it lacks a central peak. This is an indication that the crater filled up with lava, covering any central peak that might have been there. Nearby is the Alpine Valley, which is a wedge-shaped depression cutting through the mountains to the east of Plato. It's about 80 miles in length, and it varies between 4 and 6 miles wide. Another one of my favorite craters is that called Copernicus. Copernicus is also about a 60-mile wide crater, created about 900 million years ago from the impact of a small asteroid. So as things go on the moon, it's a pretty young feature. But even through a small telescope, many of Copernicus's crater features can be observed. There's several central peaks, and of course the crater walls formed by the lunar crust rebounding after the impact. There's a blanket of ejecta material and a surrounding ray system from the blasted material from the surface. There's lots of small pits and craterlets formed by larger ejected fragments that were blown up from the impact and fell down nearby, creating their own small craters. So again, a very interesting area on the moon to observe. So we're just a few years past the 50th anniversary of the first man on the moon, July 1969. So thought it would be appropriate to briefly talk a little bit about the Apollo program. And maybe we'll talk a little bit about how you can locate their general locations of the landings that you can try to observe. But as John F. Kennedy famously said, September 12th, 1962 at Rice Stadium, we choose to go to the moon. We choose to go to the moon this decade and do the other things, not because they are easy, but because they are hard. And getting to the moon in the 1960s was hard. And we did that by building the largest rocket ever created, the Saturn V rocket, which stood over 360 feet tall. And again, the majority of this is the actual rocket and rocket fuel. Up here at the top, you have the command module, service module that the astronauts rode in. Of course, the stored underneath of it was the lunar landing module that they used to land on the moon with. But again, it was not an easy thing to do. So the Apollo landing sites, of course, Apollo 11, the Columbian Eagle landed in the Sea of Tranquility, and again, July 20th, 1969, first men on the moon. There was Apollo 12, landed November 14th, 69 in the Ocean of Storms. Apollo 14, Kitty Hawk and Antares landed in the Fra Mauro Highland areas on January 31st, 1971. Apollo 15 landed July 26th, 71 at the foot of Mount Hadley in the Apennine Mountains. Apollo 16 landed April 21st, 72 in the Highland area near Crater Descartes. We're coming up on the 50th anniversary of that in a couple of weeks. And of course, Apollo 7 landed on December 7th, 1972, near Crater Lithrow in the Taurus Highland region. That was the last manned mission to the moon. So, a couple of my favorite Apollo landings. Of course, everyone's favorite, I'm sure, is Apollo 11, the first men on the moon. The Columbia Command Module and the Eagle Lunar Lander. The mission launched July 16th, 1969. They landed July 20th, spent a day or so on the moon, took off, splashed down back on the Earth July 24th. The mission commander was astronaut Neil Armstrong. The command module pilot was Michael Collins. And of course, the lunar module pilot was Edwin Buzz Aldrin. And of course, I'm sure everybody has heard Neil Armstrong's famous words when he stepped out of the lunar module onto the surface of the moon. That's one small step for man, one giant leap for mankind from the Sea of Tranquility. Now, the Eagle, again, did land in the Sea of Tranquility near the medium-sized craters of Ritter and Sabine, and also the smaller bright crater called Moltke. This is an image that I took using a Meade LX 200 GPS and 8-inch Schmidt-Cassegrain at f10 using an old Stellacam analog EX video camera with an IR filter. But anyways, Apollo 11, they explored the immediate landing area. They returned surface samples. They spent a total of 21 hours and 36 minutes on the lunar surface, of which only 2 hours and 14 minutes were actual EVAs walking around. You're again the same telescope now using a 2.8x Barlow and a 2x digital zoom on the camera, kind of pulling up a little bit of the features in the general area. My other favorite mission is that of Apollo 15, the Endeavour Command Module and the Falcon lunar lander. It was launched July 26, 1971, landed July 30th, spent a number of hours on the moon, and finally came back to Earth on August 7th. The commanding astronaut was David Scott. The command module pilot was Alfred Worden, and the lunar module pilot was James Irwin. Now, the Falcon landed at the foot of Mount Hadley in the Apennine Mountains, where they explored the Hadley Rill. It was the first use of a lunar rover, which they traveled in it for about 17 miles. They spent a total of 66 hours and 55 minutes on the lunar surface, of which 19 hours and 46 minutes were EVA, either walking or driving around the moon's surface. And again, using an 8-inch Schmidt-Cassegrain, a Barlow lens, and a 2x digital zoom, I'm able to pull out Mount Hadley. There's Hadley Rill to get the general location of where Apollo 15 landed. And with similar equipment, you can also repeat the same thing and find this landing site and all the other landing sites. So here's a slide of all the various Apollo mission patches, starting with Apollo 8. A total of 9 manned missions traveled to the moon in just under 4 years from 1968 through 1972, with 6 of those landing on the moon. Apollo 9 stayed in Earth orbit, testing out the various equipment that they were going to need. But as of this date, including all the crews of Apollo 8, 9, 10, 13, only 27 men have flown beyond low Earth orbit, higher than what the shuttle ever went or higher than the ISS currently is. And 12 of those men walked on the moon. Well, due to a variety of budget and political reasons, the last 3 planned Apollo missions, 18, 19, and 20, were canceled. Now, one of these last Apollos was targeted to land in the crater Copernicus, which I'm deeply disappointed by because, again, that's my favorite lunar crater. But parts of the remaining rockets, which were already built, were reused in the Skylab mission, and then the other 2 are on display at Cape Kennedy or at Houston. And I highly recommend, if you ever get a chance to get down to one of those 2 locations, to go there and visit them and walk around that rocket. Just be amazed at how big it is. Well, after Apollo, NASA had many successes in the manned space program: Skylab, the Space Shuttle, the ISS, and also numerous robotic exploration missions: Pioneer, Viking, Voyager, Magellan, Galileo, Cassini, Messenger, SOHO, SDO, Kepler, New Horizons, the various Mars rovers, Sojourner, Spirit, Opportunity, Curiosity, Perseverance, and the helicopter drone Ingenuity. And of course, who can forget the Hubble telescope? And now we have the Webb. Though I do feel like I've left something out. But anyways, I just wish we could have found a way to continue traveling to the moon during that time. And for a long time, I used to wonder, when would we be going back to the moon? Well, with SpaceX and now the NASA Artemis rocket, I have a feeling it could be fairly soon. So we're actually living in exciting times once again, as far as manned space flight. I think within a few years, we may see man once again back on the surface of the moon. So if you'd like to learn more about the moon, again, Bernie had a lot of great books, just a couple of my favorites. One of mine is the Moon Observer's Handbook by Fred Price. And this book has a chapter for each day of the moon, and it goes over what you can see along the Terminator on that day of the moon. Very, very useful tool to have. And finally, the Atlas of the Moon. Everybody needs a good roadmap, and this one by Anton Ruckel is one of the best moon maps I've ever seen in a printed form. And of course, the internet is your friend. Just Google the moon and you'll find all kinds of information about the moon. Well, this concludes my introduction to the moon. Now that you've learned a little bit about the moon's phases and features, perhaps the next time that you look at the moon, you'll see it as another world, in some ways similar to our own, but in many important ways completely different. So if you'd like to learn more about the moon, see some of the various images and sketches I've done over the years, you can go to my website here, stellar-journeys.org, and scroll down the table of contents. I have a solar system tour page, which has a section on the moon. And of course, I have an Apollo tour page, which is focused mainly on how to find the Apollo landing sites. So with that, that does conclude my presentation, and I will be happy to take any questions you might have on observing the moon. So Bernie, I turn the floor back over to you.
Well, thank you so very, very much. Give people time to turn their microphones back on so that they can, oh, I'm getting a can't start video again. Okay, well, you don't need to see my face. Everybody knows what I look like. Do we have questions for Larry?
I know we're all deep sky observers here. I know the moon.
Okay.
I don't see any in the chat right now, but if someone has one and would like to just turn on their mic and ask, that would be perfectly fine. Oh, one just popped up in the chat. I'll ask this one. Is the feature called the tower on the moon really that unusual and real?
Oh, you know what? I think you just stopped me. I've not heard of that feature.
Doesn't ring a bell with me either.
Yeah. Can the person asking the question, can they elaborate a little? They know where the general location is located at?
The question's from Doug Curry. I'll let him, give him a minute or so to reply back, and I will let you know.
I have a question.
Go ahead.
All right. What is it about the moon that is hollow? Is that a true fact, or is it hollow?
No, it's not hollow. Jules Verne proved that, remember?
Yeah. Well, that was the question, maybe because some people have been saying that an object had hit the moon and it rang for quite a while.
Oh yeah. Oh yeah. That's true. It will ring. Yeah, just like the Earth. Yeah,
okay, so it does.
Yeah, I mean, it's not hollow, but it will. You know, the seismic waves, just like how the earthquake here on the Earth. Yeah, that's how we earthquakes, and they're setting off seismic charges. That's those generate sound waves that will actually travel through the Earth, and that's how science has learned much about the interior of the Earth. And it's the same way with the moon too.
Okay,
but it is a solid.
There's no aliens living on there, is there?
No. You have to go to Mars for that.
Mars for that, yeah.
And try as you might, I've tried and tried and tried. I still can't find Alice Cramden on the moon either.
Larry, we have another.
I was thinking about the Tower of the Moon. Though. There is something, and I wish I had my one notebook here. I cut out things from Sky and Telescope. I got one. I think it's called the City on the Moon, and it's just a feature of like low mounds and stuff that at sunrise it kind of looks like an ancient city, like with ramparts and stuff like that. I'm wondering if that's what the questioner was thinking of. Maybe I can't remember the exact name of it, but it's like City on the Moon or something like that.
So Larry, we have a question from Matthew. What's your
Yes.
favorite scope for looking at the moon?
My favorite scope, the biggest one I can find. Gee, really, you know what? It all depends. Like I have like a little 80mm refractor, like f6.3, and that's great for looking at the moon. That shows the wide field features, the mare, that kind of thing. Of course, I have my 8-inch Schmidt Cassegrain. I use that a lot, but I also like to look through bigger scopes too at the moon. So really, there's no one telescope that's best for the moon. It's really the telescope that you have. That's what's best for you for the moon. And again, there's so much features on the moon: mountain ranges, craters, valleys. There's so much there that you can see with any kind of instrument.
Yeah, I just purchased. Sorry.
Oh, sorry, Larry. Go ahead.
Yeah, I just purchased a. What's the name of it now? Well, anyways, it's a 4-inch scope, and I like it a lot. It really shows a lot of the features of the moon, and I use different lenses. I'm only new to the hobby, so I'm finding that I get a lot of good features off the moon with my 4-inch. It's can't think of the name of it now, but I'll come back to you and I'll tell you what it is.
Okay, I see there's a follow-up question on the chat there about the Barlow. So at the time for those particular images on the Apollo landing sites, I was using a 2.8x Barlow. Is a Klee Barlow sold by University Optics, that some of you may remember. And then the camera I was using was an old Stellacam EX analog video camera, 1/2-inch CCD chip. And the camera allowed you to do a 2x digital zoom on board on the camera. And that's what I was using too.
We have a number of questions here in the chat. One, I don't know if everyone saw this, but this came from Daniel Baird. And he said, interesting to hear Colonel James B. Irwin's name tonight. Crazy true story. Had supper with him about 30 years ago. One of the most interesting evenings of my life. So at some point in time, we're going to need to hear more about that one. I do have a follow-up from Doug Curry about the tower. He believes the feature is supposed to be around the crater Alexander by one end of the Sea of Serenity. Does
Yeah.
that help at all?
I don't know. That's a new one on me.
Okay.
I'll have to add it to my list of things to look.
Sue,
My
I
next-
just did a quick check on the internet, and it indicated the crater Marcenius E. There are a whole long list of craters. Marcenius is the larger one, it's 15 kilometers. And there's a small one that's sort of formed on the rim that from certain angles looks like it's actually projecting above the surface. It's just an illusion, essentially. Marcenius.
Well, you'll have a chance to check it out because Mersenius is one of the targets on the new program.
Our
Yes.
next question is, oh, sorry, John. Oh, I'm going to move
No,
on to our next question, but thank you for doing that. From Gary Haslam, do you think the Chinese will be the next to land a man on the moon?
I don't know if they'll be next, but I think they will be. Yeah, I think from what I understand, the NASA Artemis, I think that could be in the next couple of years if again, if SpaceX doesn't beat them to it. So of course they just may bypass the moon and go straight to Mars. But I think the Chinese will be there soon, probably within this decade, I would imagine.
Our next question is a follow-up from Paul about the Barlows. He asks if you could repeat what eyepiece you were using with that Barlow.
Oh, okay. Well, again, that was a camera on that I was using. So again, it was an old Stellacam EX analog video camera. There's another. They don't make those anymore, but there's a lot of modern ones that you can buy. Malin cams, for example, are good cameras. Of course, these days, I think most people have kind of transitioned from the analog over to the CMOS type cameras, like the ones from ZWO, the planetary cameras for just a few $100s. They are really great. They work really well.
Thank you. Our next comment is from Yvonne. Thanks and a great presentation. As a beginner, I learned a lot about the moon tonight I didn't know. Like you said, the moon is fascinating and easy to see. And
Excellent.
I have another question from Doug Curry. He asks, what are the smallest aperture telescope or binoculars that could see some of the entrances to the lava tubes?
Okay, give me
That's
a
good.
size on the size of the lava tube entrance.
Yeah, that's a good question. I'm not sure. Yeah, I don't know. Yeah.
A 14-inch scope will resolve you down to 0.63 kilometers. So that's 600 meters across on the moon. And I dare say that a lava tube would be somewhat smaller than that. So you're probably looking a very large scope.
Yeah.
We're talking, talking meters now.
Yeah, to put it in perspective there, when I was showing that slide on the Apollo 15 landing area near Mount Hadley, you could see the rill there that they explored. The rills are generally collapsed lava tubes. And so that was, again, that was of an 8-inch spectroscopy using a 2.x Barlow, and of course a 2x digital zoom on the camera.
Well, and of course it all depends as well. Like you can see, as you said, the rills and such in the various seas and stuff. I was thinking he was thinking the collapsed end of the smaller tubes, but
yeah. Yeah, it also, you want to factor in the time when you go to observe it. You probably want to catch something like that near lunar sunrise just afterwards, when you get a lot of shadows, because something like that, like full moon, for example, it's, all the details are washed out. It'd make it much more difficult looking for some fine detail like that.
Although speaking of full moon, there are some objects that are visible at the full moon that are best at the full moon.
Yes, yes.
Like the headlights and such over by Kepler, or not Kepler, over on the east side. Lots of good stuff. So it's a month-round target, the moon.
Yeah. Just because the moon's full doesn't mean it's not worth looking at. Again, all the various crater ray systems around Copernicus and particularly Tycho, that's the time you want to look for those things.
And it's also one of the better times to look for your libration objects too.
Doug has popped a link to an article about the mystery alien tower solved. So if anyone wants to read a little bit about it, that link is in the chat.
Awesome.
And I think, oh, here we go. I have another question. Can you suggest eyepieces? This is from Paul Gross. Can you suggest eyepieces, not cameras? I am a beginner and would appreciate the guidance. I noticed the moon is so bright, a high magnification lens is too bright to get detail. Definitely.
Filters.
Yeah, filters are your friend. Eyepiece filters, or you can actually handhold them too. And you really, I mean, I think they say green filters are for the moon, but you can use any color filter you got. Just try different ones. If you have like a filter slider, or a filter wheel, those make it easier. Eyepieces, generally, well, like I guess it's like with any kind of object. You want to start off with your lower power, your higher millimeters. And then when you find the particular object on the moon that you want to watch, you want to look at in greater detail, you do want to switch over to the higher magnifications. You maybe try 8 millimeter, something like that, 6 millimeter. But a lot of it's going to depend on the conditions too, what the seeing is like, as to how much magnification you can use on any given telescope on any given night. The thing is to experiment. Don't be afraid to try high magnifications.
We have a question from Brett Tatton, and he asks, do you recommend a polarizing filter?
Yeah, they work well. You can use those in place of an eyepiece filter, especially I like the variable ones where you can turn it and adjust it. So that way you can have minimal polarization. If it's dim object, or if it's bright, you can really tweak the polarization to cut the brightness down.
I have another question. I have a Celestron scope, and I put my camera on the end of it, and my Celestron SE4. It has a tendency to move the scope down all the time. Is there a way of sliding their scope head further forward, or would that help compensate?
What you need to do is counterbalance it, and the best way to do that is get yourself a set of like rails to put on it, maybe top, bottom, and get a little some of the weights. Various companies make kits, for balancing something like that. But yeah, when you put cameras on the tailpiece in, it does throw it off.
Yeah, I have a difficult trying to take pictures with it. Just every time I take a picture, the camera starts dropping down because it's covered with weight. So is there such a thing for a Celestron system, I guess, or do I have to look that up?
You'll have to look and see if they make something for your type of telescope. But you do, I mean, if you're going to do imaging of the moon, or really anything, you do need a substantial mount. That's a lot of people, that's where they spend their money, on the mount, not necessarily the optics.
Yeah.
Oh, okay.
Larry, your telescope that you're referring to, that's one of the side mounted?
Yeah.
Yeah. Okay.
Well, I want the red, the models are the red in color.
Yeah. One I would suggest as a quick fix is get yourself a grocery bag, plastic grocery bag, spread the handle open a little wider, put it over the top end of your telescope, and just fill it in with a little bit of weight to adjust the balance.
Dave, a little bit of groceries in there might help the balance.
Oh yeah, and as you go through the night, when the food's done, you're gone. You go home.
Yeah, it might be a problem if you get hungry, though. It may start rising on you as you enter the bag. That actually does give me another idea too. What you could do, you don't necessarily have to buy these expensive counterweight systems. A little Velcro and like a homemade bean bag with some, like lead shot or, lead sinkers for fishing or whatever, strip of
sand.
Velcro, you can adjust that,
Sand
find the sweet
works,
spot.
anything like that.
Yeah.
Sand would be good because you can control it.
The only
Or
thing
weight.
that you have to worry about is your tipping to the side.
Optics.
Yeah.
Okay.
Yeah, we'll have to play around with that one.
So just
Yeah.
go easy with it. Put a couple of pillows beside it just in case, right?
Well, I don't think it'll tip over. It's pretty strong. It's a good stand on this unit, so.
Yeah.
I gotta try. Yeah.
Good stuff.
I was just reading the question in the chat about separating the halves of polarizing filter. And you know what? I've never tried that, but that would be an interesting experiment. I think that might work.
I don't understand why somebody would want to separate them, because the whole idea is for it to work in concert.
Yeah, well, I can see where, like, depending on, again, your eyepiece, you're using a diagonal, you put the polarizing on it and it goes into the diagonal. It might be too far down into the diagonal for you to actually be able to twist it.
I can explain.
Okay, please do.
You have a polarizing filter. It's actually two filters, and you rotate them to achieve a certain amount of light blocking.
Mhm.
But if you want to change it, you have to take the eyepiece out and guess at where you want to move it. But if you separate the halves, whether you use a tube extension or place the other half one place or the other, it's the orientation between the two. It doesn't matter how far apart they are.
Mhm. Right, good idea.
Because you do rotate it. Sometimes I just hold it up to the moon and I turn it and say that's good enough and plug it in the telescope. But if you want to, you can fine tune it while it's in the telescope. That's why I bought 1 1.25 inch and one 2-inch polarizing filter. I just leave the 2-inch one in the front of my 2-inch diagonal.
Yeah, that works. A lot of people do that. A lot of people do that.
Yeah, on mine, what I did is I took one of my diagonals and I drilled a new hole for a set screw, and I put it close to the lip of the diagonal. And that way, when I would put the eyepiece in with the two polarizers, you got to be a little careful when you do it, but you put it in where the first one's in there and you tighten the screw against it. Then you can turn the eyepiece and the first one stays.
Okay, I
So
see. What you're talking
you got to have a little bit of drilling skills there. So drill,
Yeah, and then tap it as well.
Right. Yeah. You want to use a tap. Yeah, definitely.
Terrific.
Bernie,
Yes.
there's a good question as we wrap up kind of our question period. There's a good question in the chat from Paul Gross.
Yep. I see it here.
He is wondering when we might be getting together in the field as a group to do some observing.
As soon as possible is the preferred answer to that. Is something that council right now is working on, getting set up. We have the okay to go to the park from the Conservation Authority. We will be in touch with everybody real soon on that. Just watch your monkey mail or watch your email for monkey mail blast, letting you know that the park will be open. It'll be happening very soon. As soon as we get the weather. That's the other thing. I don't think we've had a clear night in months.
And with that, Bernie, there are no more questions in the chat that I see at this point in time.
Awesome. Well, thank you, everybody that has participated in this quiz period. Thank you, Larry, for your fine presentation. You covered quite a few things that I did not, but I sort of figured you would be covering those. We usually take a bit of a break at this point, and I think we might as well do that. What time is it? It is 8:49, so we'll call it 8:50. If we can be back in 5 minutes at 8:55, give everybody a chance to get up, stretch, go tinkles, whatever, and come back in 5 minutes. We'll continue on.
Okay. All right, Bernie, I want to drop off for the evening. Again, thank you very much for inviting me to present tonight to the Hamilton Club. I really enjoyed it. And again, I hope to get a chance to see some of you down at Cherry Springs this summer.
I hope to be there. We all hope to be there.
Awesome. Good. Thanks a lot. Pleasure seeing you all again.
Larry, thank you.
Thank you, guys.
Okay.
Thanks,
and we'll be-
Larry.
Okay, we'll be back in
Thank
5
you, Larry.
but talk amongst yourselves. Oh,
Boss.
thank you. Thank you all. Welcome back, everybody. As I said, the family Whitman is not with us tonight, and I have a couple of books to give away. I'm not going to hold them up again. I already told everybody what they were. Well, I should do that again anyway. Sorry. We have a moon theme happening tonight for the most part. We have the Firefly Moon Observer's Guide. I can't show it to you because I know it never shows well. Oh, there we go. You had a brief second of it. There you go. We have John Reid's 50 Things to See on the Moon. It just goes and then it just disappears. Okay. And not moon related, we have a Firefly Planisphere again. Nice big one for you to use out in the field. They're not here, so I've done the draws. Just randomly wrote down some numbers and then I counted down the list of attendees, and the winners are Doug Turner. Where are you? I know Doug's here somewhere, or he should be.
I'm here, Bernie.
There you are. Okay,
Woohoo.
good. Okay. And we have Yvonne. I know she's around here somewhere, or she was. There she is. I see her. Yeah, there she comes.
Cool.
Cool, yes.
I'll have the planisphere.
The planisphere, awesome. Good for you. Okay, and we have Joanne. Joanne, believe it or not, you are a winner today. You don't often win. You're a winner all the time. Your microphone.
Thanks, Bernie.
You're very welcome. We'll be in touch and we'll figure out who's getting what. But we know Planisphere has already been claimed by Yvonne.
And I already have the little moon atlas, the little one. I got that. I won that one once.
Which the 50 Things to See on the Moon?
No, the other one.
Of the Firefly.
Yeah.
Okay.
So if Doug wants the 50 Things to See on the Moon, maybe there's something else I can get from you instead.
Yep. Yeah,
Joanne, go
we can
ahead
work
and-
something out.
Go ahead and take the book. I can use a moon atlas.
You sure?
Absolutely.
Okay, win, win, win.
There you go. Awesome.
Thank you.
Thank you, guys. Okay, so now we have, where are we going? Sue, you have
Yes.
some talking to do for us.
I do, and I will try and make it as brief as possible. I'm just going to share my screen here. Hang on 1 second. There we go. That's the right screen I want to share.
Yeah, we don't have any share yet.
No, I know, because I
Oh.
had the wrong screen. So
There
here's
you
the right one.
go.
Okay, so for those of you that have been on the meeting last month, I talked about our opportunity to do some dark sky stargazing on Dave Skelton's property on the Bruce Peninsula. And Matthew and Janice, his wife, and Doug and I have been working on this, and we have got all of the information you need uploaded to the website. So if you go to our Hamilton Amateur Astronomers website and you click on Club Events, everything is here underneath the Star Party. So we've got some general information. We've got Star Party accommodations both on and off site. We've got some Star Party activities, some tips for having a good time at a Star Party, and then some rules that we're going to follow on site. And those rules are basically the same for every Star Party that you would go to. So just a couple of things that I'm going to highlight tonight, because those of you who are interested can go and read through some of this on your own, just so that you know this is not the site we will be at. This is actually a picture of Starfest. And if Michael Jefferson is here, that's his car and his tent right there in the banner. Just some information. The cost is going to be $25 per adult, 18 years of age and over, and $10 per child, 17 to 18 years. Children under 11 will be free. And this cost will cover the cost of the porta potty rentals and the insurance costs that the club has to take on for this event. And this will be a rain or shine event, as most star parties are, and refunds will only be given in the event that a cancellation has to happen due to COVID restrictions. And then I have some other information that's here about driving time, about services in the area, the on-site accommodations, and then staying off-site. The off-site people, you can leave your telescope at Andromeda Meadow overnight, but the equipment must be covered, and we ask that you take all of your other assorted eyepieces, books, etc. With you when you leave at night. The other, come on, go back here. The other one that I just want to highlight are the activities, which should open up here. Here, there's some more information about the 2 observatory tours. So the first one is at the E.S. Fox Observatory that's run by the Blue Water Astronomical Society. And the second one, there's very little information here because this is a private tour at a private residence. And they can only accommodate 15 participants and 3 cars-ish. And if you're interested in going to see, it's a double observatory. So there are 2 domed observatories at the site. You need to contact either myself at starparty@amateurastronomy.org or Matthew at Observing if you're interested in the tour. And then you'll receive all of the information about it once you arrive on site in September. We're going to have a couple of cafes in the morning. Matthew, I think, is going to run a coffee and little tea cafe in the morning at the Bunkie registration tent, and bring your own mug, spoon, etc., and make a small donation to help us cover the cost. And then we'll have a potluck dinner on Saturday evening. And the information is there. I'm also looking for a volunteer wants to go, who will help with the potluck. Lots of other activities. All the links are here in case you're looking for something to do up on the Bruce Peninsula. And as I said, there's lots of other information here under club events, under Star Party. The only other thing that I'm about is the registration form. The registration form will be active online tomorrow morning after 10 o'clock in the morning. And the payment is where Chris and Doug are working on making PayPal work for us to actually handle the payment for this. And they're working on that in the background. So when you register, I will be sending you an email back telling you how much you owe and giving you the links. And if we can't make PayPal work, then it's probably going to have to be a check, but we would much prefer to go through email. So those of you who do register, I will be sending you an email back. And just so that you know, there will be a cap on the number of people, both on-site and off-site, because we have to ensure there's enough space on the 2 observing fields for everybody to put their stuff. So a waiting list will be created if need be, but I will let people know that when the registrations are full. So if you're interested in going, there's lots of information there to go and have a look at. It's a beautiful site, and we're hoping we're going to have clear skies, and we're going to have a great time and sharing our hobby together up on the Bruce Peninsula. And thanks to Dave Skelton for inviting us. And as always, if there's any questions, I'm available at starparty@amateurastronomy.org.
Awesome.
Are there any questions, quick questions right now before I go?
Nope.
Okay. Bernie, it's all yours. Thank you.
Well, thank you. Thank you very, very much for jumping in, organizing this, and then getting it out to us in a timely fashion. Okay, so we now have, I believe, Chris, I believe you wanted a few minutes.
Yeah, I can get it done in a quick minute. So basically what I wanted to provide the membership with an update on is for those of you that are Facebook users, we now have a Facebook page that's called Hamilton Amateur Astronomers Club Member Interactive. So that's exclusive for the club's members, where you can post pictures, start conversations related to astronomy, some Q&A, and just a general place where you can interact with other like-minded individuals from the club. So again, if you go to Facebook, you can just do a search for Hamilton Amateur Astronomers Club Member Interactive, or visit our resources page on our website, and that'll have a link to that page right there. So it'll ask you for some basic information, just confirming that you're a member of the club, and upon approval, you'll have access and post and communicate to your heart's content. So
Great.
that's it.
Awesome. Thank you very much. And that brings us around to that golden hour, or the golden guy himself, Matthew.
Jeez.
This guy.
All right, Bernie. All right. Okay. Let's see here. I'll try and get this set up. Oh, what the heck's the one? Hide. There we go. All right. Hello, everybody. Welcome to the Sky This Month for April 2022. I'm going to start this month up with talking about the planets. And most of the planets, the next 2-3 months, are in the morning sky. And they have to be up pretty early to see them. But there is 4, or will be very shortly, 4 naked eye visible planets in the morning sky, with Saturn furthest west, followed by Mars, Venus, and Jupiter. You'll notice that Neptune is also there. It's not naked eye, it's almost magnitude 8, which means that you need binoculars to see it. There's going to be some really close conjunctions with, for instance, Venus later in the month, and it's going to be helpful though whether you be able to pick up Neptune in the background on light. Certainly you could give it a go and see if you can see Neptune. It's going to be very dim and like I said, hard to pick up. So I decided to experiment, and I made a stop action movie of the next 20 or 22 or so mornings rather, excuse me, to show the planets as they move, and show Jupiter rising, all this kind of stuff. So let's start it. So there's Saturn, Mars, Venus, and you're about to see Jupiter come up on the 15th or 16th, the Neptune appearing, and if you notice, Venus is moving east towards Jupiter, and the moon is coming down. So on the 27th, it makes a great triangle with Jupiter and Venus, and at the end of the month, Jupiter and Venus will be extremely close together. They'll be close enough that you can see them both in the same field of view in your eyepiece. So dead easy in binoculars, and certainly with a wide field eyepiece in your telescope, you should be able to get them both in the same field of view. So lots of opportunities for looking at the planets. As the month goes by, as we get more towards summer, you'll notice that there's more and more light pollution in the sky earlier and earlier because the sun is coming up. And but you should still have ample opportunities to see them. I saw Venus the other day. It was super bright, and it was already well after, dawn. So I would say that others are probably going to be pretty easy too. I just have to get up earlier, and I'm not really very good at that. Anyways, there's one naked eye planet in the evening for the second half of the month, and that's Mercury, and it's making its show of the year For us in the Northern Hemisphere, it'll be just north of west in the evening twilight. You'll see that the Pleiades are a bit there. And, you know, if you wait until Mercury gets much lower to the horizon after about half an hour from when it's at this height, you should be able to pick up the Pleiades as well quite easily above it. You can see this is on the 22nd. This is sort of the mid period for this particular viewing of Mercury, and it's 8:45 in the evening. And Mercury here, you look up at the left, is at 11.5 degrees above the horizon. So that's a really nice height for Mercury. Often it doesn't get much above 8 degrees. So this is a nice height, and you should be able to see it naked eye. You'll be able to see it a bit sooner with binoculars to help you find it. But it's pretty awesome. If you haven't seen it before, have a look for Mercury. Coming up on April 22nd for that week, it's the International Dark Sky Week, and they have a program called Discover the Night. Now, I did look to see if there was any events in the area here, basically Southern Ontario, and I can't find anything. I can't find any events that are set up right now, probably because of COVID. Certainly, there's nothing to stop you from finding out more about light pollution if you would like to, and certainly going out and discovering the night all by yourself. Now, this is early for me to be bringing up. Mid-May is a total lunar eclipse. It's going to be awesome. Hopefully, the skies will be clear. May is usually not too bad. And this one starts on May 15th at around 10:30 and finishes on the 16th early in the morning. And this is a really, really nice one. Here's the moon right here, just about to go into the umbra, the Earth's shadow. So this is first contact, and that's at 10:27 in the evening. By 11:30, the moon will be completely in the Earth's shadow, and it'll be there for about 1 hour and 25 minutes, if I remember correctly, going across through the shadow. The moment of greatest eclipse is at 12:11, and that is the point as the moon traverses the shadow where it's closest to the center of the shadow. So really, you're actually going from the edge this way towards the center. This is the point of closest or maximum eclipse. Well, then it makes contact again with the edge of the shadow at about 5:01 in the morning. And after that, of course, the sun starts taking beats out of the moon. And after another, hour and a half, it'll be completely out of the shadow. When the moon is in the penumbra, which is sort of the outer shadow of from the Earth, you really won't be able to see any difference visually between when it's there or out here. I've never been able to tell the difference. When it gets into the main shadow, it takes on that beautiful rusty red tone. And sometimes, like the last one we had, it was very, very dark. I was amazed at how dark it was. That was minus about 15 or 17 that night. This one should be a little bit nicer to stay outside and watch. I'll bring it up again briefly next month. I wanted to give people ample opportunity to know about it. And Bernie will be happy about this. I brought it up. It's 2 years today until the solar eclipse, the big one. And that's in 2024 on April 8th. And here's the path of totality, starting in the Southern Pacific there, and then coming up across North America and out into the North Atlantic. And we are very, very close to the center line in Brantford Hamilton area. I've actually shown a dot here on the map. There's Niagara Falls and Niagara on the Lake and Fort Erie. This is extremely close to the center of the area of maximum eclipse, the center line. And here you can see that totality lasts 3 minutes, 45 seconds, which is a really nice long period of time. And you can see it starts at 2:04 and ends at, sorry, 3:18, till 3:22. There you go. That's the period where we're in totality. But the actual partial eclipse starts at 2:04. So it's mid-afternoon. It's going to be really awesome. The weather outlook is not really good. It's about a 35% chance of it being clear. I actually looked up and down the path from Newfoundland all the way down to Texas, and actually it doesn't get much better no matter where you are. The best was about a 40% chance. So we'll just have to hope. And we've got 2 years to think about it. Yeah, that's one of the things I'm looking forward to in the fairly near term. I was on CNN reading some of their articles the other day and last week, and I saw this article by Kirsten Fisher, how satellites are polluting our night sky, and this is becoming a huge issue. And I have a lot of issues with it, but not much I can do about it. Anyways, she went to Saskatchewan to interview Samantha Lawler, an assistant professor of astronomy at the University of Regina. And they went out and stood in the field and with a nice telescope, and we're looking at the sky and started seeing all these satellites flying across already. So there's a really good video in this article, which you can look up on CNN, and it gives you a synopsis of the article and a few other bits of information as well. But the main point I got out of it was that by 2030 or so, 1 of every 15 points of light in the night sky will be a satellite. Think about that. Think about trying to observe a star field and some of it's moving all over the place. It's going to be quite difficult. Anyways, these couple of pictures are from the article itself. So this gives you an idea of the sort of number of satellites that are up there now in the sky. And this is what they anticipate in about 8 to 10 years. That's not good. It's the only thing I can say. I mean, there's going to be upwards of 70,000 satellites up there by that point. Now, I put in the event horizon in my article that I had worked on my CG4 mount, that it was really sticky and that I had done some maintenance on it. And I thought I'd talk about it a little bit because, you know, most of us tearing our equipment apart is a bit scary, right? Because it's expensive equipment. However, the CG4, at least when I bought it used, was quite cheap. And over the last fall, over the winter, I noticed that RA axis, which is the axis that the weight swings on here, this is the RA axis, you could swing the weights almost to the top and let go, and they would just stay there. And that's with the lock off on the axis. So they should just swing down and go like a pendulum a few times and then come to a stop somewhere near the center bottom. And that wasn't happening. Also, I had lots of problems with backlash. Backlash happens, say, for instance, on the deck axis, you put the lock on for the axis, so it shouldn't move. You can put your hand on it, and if you can tweak it back and forth a little bit, that's play in the axis. So if you're looking through the telescope and you use your little slow motion gizmo there, you'll actually start turning it and nothing will happen until the worm gear inside the head makes good contact and the axis will start to move. And you can get similar amounts of play in the RA axis as well. You could lock it, and if you can hold on to the weights and move them side to side a little bit, then there's backlash there as well. And it's to be expected in a really expensive mount. All mounts eventually get it. My EQ6R, which is a much bigger, heavier mount, has backlash developing in it because the bolts are getting loose. That every year or two you have to tighten them up, and also set the worm gears in it. So what I did was I watched a few videos, but apparently I didn't watch the right ones, because what happened was I started taking it apart and I hit a really, really big problem. But before I talk about that, I'd better talk about the mounts just a tiny bit. It can handle up to about 10 kilos just for visual use. You can buy a motor set for the 2 axes and a very simple up, down, left, right controller so that you can adjust its positioning without using the cables there. I usually just put the axis on and polar align it and let it just once I'm on a target. It works great for the sun, for instance, with a solar scope. Now, up until 6 months ago or so, when the prices went insane, it was about $400 for this mount, as you see it, and it was $400 for years. And the motor set was about 150 bucks. Well, now the mount is 600 and the motor kit 240. It's gone up 50%, and everything else has gone up between 25 and 50%. I would not consider this a good value mount at this point at these prices. You can go just a few $100s more and get an EQ 35 mount that's fully O2, and I would consider that more of an option than this. But if you could find one used and you want just a quick grab and go setup with a small refractor or a small Schmidt or anything like that, it's an awesome mount to take outside, set up, point at your target manually, and just let it go. It's a great mount for that. Anyways, I'm gonna do the maintenance. Main problem, or one of the main problems with these mounts with the stickiness is that you put in this horrible grease in all these mounts that are made in China, and they have done for years and years and years and years. So what you do when you take it apart is you clean all the gunk out of it and any of the dirt and grime and any bits of metal shavings that they've left in there, which does happen. Get it all out, and then use a really good premium grease in there. It's not expensive. It's like $8 a tube. There's different ones, but what you really want to look for is this wording here, which is safe on metal, rubber, plastic, wood fabrics, and painted surfaces. Excellent for high pressure and load bearing applications. Superior resistance to corrosion, water washout, and extreme weather conditions. So this is the type of stuff you want, because all these things are an issue with your mount when you take it outside. And especially when you put a lot of weight on it, you'll end up with a lot of load on it. Here's the issue that I had, which caused me some consternation and some damage to the inside of my mount, unfortunately. So I'm telling everybody so you don't make the same mistake. In the RA axis, this is the RA axis on the left. There's your polar scope, polar alignment scope. Okay, inside there, right under this screw, is this lock washer or lock nut. You can call it whichever you want. It screws on to the axis itself on these threads. And when you tighten it up, it actually holds the two halves of the RA axis together, the front half and the back half, and makes it tight. What happens is when they build these things, apparently they like to really torque this washer on really hard, and it causes the mount to become extremely sticky and hard to use, really. It's hard to balance your telescope and counterweight it when nothing moves because it's stuck. You see these two little holes here? This is to use a tool. You stick in both holes at the same time and you turn it. It's the same type of tool that you would use on filters for your telescope or camera, where they've got the little slots on the ring that holds the filter in place, lens assemblies in your telescope, all kinds of things to do with optics. Use these types of tool. So this is the tool. I wish I had had one. It would have been a lot easier. I didn't. I'm going to get one. But that's the sort of tool you want. It's like 25 bucks and it has multiple uses, so it's not too expensive. Now, here's that ring. This one fella, he's got it out. You can see these gouges in the aluminum. I've got quite a few gouges in mine because I couldn't get the darn thing to move. I looked for little grub screws to see if it was actually fixed to the threads. I didn't see any, and so I tried to get it off, and I made one heck of a mess of this piece of aluminum. Luckily, I was able to smooth it all out with a file, and it went together, no problem. I was lucky, but I'm trying to avoid this bit and get rid of the issue. And on this mount, there are no bearings at all in either axis. What you have is machine surfaces and these little plastic washers. So when you take it apart, you're going to clean the washers, you're going to clean all the metal parts and re-grease everything. You can be fairly liberal with grease, but you don't need a lot of it. When you reassemble the RA axis and you put this ring back on, and tighten it until as much as you can, and then give it a little bit of a tweak, hopefully with that tool, and then check that RA axis to make sure there's no play from front to back. You can't like pull it apart slightly or anything. Then spin the axis and see if it's free moving. If it gets stuck like it did before, this ring is too tight, and just undo it like 1/8 of a turn and try again until you find the best spot. You're never going to be completely perfect because, like I said, this is a very rudimentary mount, not made very tight tolerances, to put it mildly, but you can really improve the mount. You can see the markings on the threads here. I've got some as well now, and so do a bunch of other people who tried to do this, because there are little grub screws that they drilled 3 holes at 120 degrees apart, and there's little 3 or 4 millimeter tall grub screws in each hole, 1 in each, that lock this to the threads. If you don't know they're there, you will try and turn this and scrape the grub screws right across the threads, which doesn't do them much good. The other issue I found, which is the same as this guy, was, and I can't verify this, but he thought there's some kind of super glue actually on the threaded part here, because even after I did loosen everything up, it was hard to move this thing. So, it's a bit of a game to see if you can do this. If you're not really mechanically minded, I wouldn't try it on your own. If you are, then it's just something to look out for. And the way you access these grub screws is you have to take the silver screw here out, which I didn't realize, run your Allen key down and straight inside here, undo the screws, and then back them off just enough so you can undo this. And here's another fella. You can see now the edge of the lock washer. You can see the hole where the grub screws are, and you can see he undid his first, and there's still a mark on the thread. So, not the best mount. It does do what it's designed to do, which is to get outside and viewing. So the main thing is to watch a few YouTube videos. There's lots of good instructional ones. Cloudy Nights has people who have made all the same mistakes I made, and talks about it, and it has lots of information. Make sure you have the correct tools. I was short one, and it was the one I needed the most. So make sure you have the correct tools. And if you're going to set the backlash on your worm gears, then this is not difficult to do. It really isn't. If you watch the videos, it's really pretty straightforward, and you're only talking about 3 or 4 screws that you adjust. And if you don't get it right, you just try again until you get it. You're talking about very small amounts of turning on each of those screws to get them to the right position. But it is entirely doable. And if I can do it, I would think most people can, without making that one mistake that I made. And that's it. I'm done for the night. Thank you.
Well, thank you, Matt. That's awesome. You're still sharing, but that's okay.
Yeah, I got rid of it.
Okay, good. Thank you. Yeah, it looks like you had some fun there.
I did. Once I figured it out, it was fine, but I missed that one thing. Didn't help.
Well, that happens from time to time, I guess.
Yeah, I did mine too on the AVX, and has exactly the same grub screws. And I did all new bearings, but all new tapered bearings in mine.
And that's nice. You can do that on the AVX, and it makes a huge difference. But on the CG4, there are no bearings at all.
Oh,
Anyway, thank you, Matt. Thank you, Chris. Thank you, Sue. Thank you, Larry. Thank you, me. Oh, you got to thank everybody, right? Congratulations to our winners tonight. We will, yes, I was going to mention, before everybody signs off and such, you might want to open up your Zoom chat And I just discovered this 2 months ago and forgot to mention it. If you go there and you select all the detail, all the lines in there, copy them, and take them and print them on, save them onto a sheet in WordPerfect or whatever, you can then close your Zoom and you will have all the notes from the meeting. It's just a simple way to not, or to go, what the hell was he talking about?
Not sure.
So anyway, I just highlighted mine, go Control C. I've got mine saved in my memory at the moment, so I can close that. And I'll give you guys a chance. Whoops, no, that's closed meeting. I don't want to do that yet. There we go. Close that. There we go. And that's it, folks. We will see you next month. In the meantime, please have some clear skies. Take care of yourselves, and we'll see you back here soon.
Good night, all.
Good night, all.
Thank you, Bertie. Cheers.
Good night.
Thanks,
Night,
everyone.
everybody.
Hey, guys. Wherever our camera is.
Bye.
Bye.
Good night.
There's guys, everyone.
There.
Thanks, everyone. Good night.
Good job on enemy.
Everyone.